Okay, welcome. Thanks for joining our talk. We're engineers from Stream Machine, which is a company and a platform. And the goal of what we're doing is to provide fast, privacy-secured customer data, event data that you can actually use. So in this talk, we're going to give you a brief overview of what Stream Machine is, and what benefits it can offer for event processing. And we're going to demo how you interact as a developer with the Stream Machine platform. So our goal, the goal of the company, is to provide a platform for event processing where the privacy issues that are very tightly coupled to event processing, customer data processing, are the concerns about that are taken care of by the Stream Machine platform. And this talk we're going to show you what those principles are that we're doing. Who are we? Well, I'm Bart van Deenen. I'm the first engineer of Stream Machine, not necessarily the lead engineer. I was previously at, for instance, bol.com at KPN, but also I originally come from an aerospace background, working at ESA. So I sort of went from what we call hard real-time processing, which is microsecond latency and less, to currently soft real-time, which is milliseconds. Stream Machine is still plenty fast, so I'm okay with that. I love Erlang programming and rock climbing and programming in general. So that's my background. Let me introduce you, my colleague.
Hi all, my name is Trietsch. I'm a software engineer at OpenValue, currently working for Stream Machine. I previously worked at bol.com, where I also met Bart. We briefly worked together, but now we're working together for a longer period. About me, I'm a big fan of Kotlin, and well, I mostly use JVM technologies and data engineering, the data engineering stack. Such as Kafka, which Stream Machine is also built on. I'll give the word back to Bart.
All right. So, Stream Machine was founded, the company was founded, and the ideas of the platform are built to solve the problems that teams have, that data teams in companies have, that struggle with balancing privacy, both on a moral level and on a legal level. The GDPR is very, very important in this level. And so we want to, companies struggle with finding the balance between innovation and privacy, and which often amounts to a data scientist, a data science team receives data, and the data scientists think, can I use this for the purpose that I have? Am I even allowed to see these data? Can I store it? What if there's a right to be forgotten request? How do we get rid of this data? All those questions are very real in a company of any scale. If you look at, for instance, the GDPR, it says that data have to be acquired for a specific purpose. You can't just acquire everything and decide on a purpose afterwards. So currently, most companies handle this or don't handle it, but leave it up to the data science teams, and they are often struggling with this. Stream Machine aims to solve this. So companies are also having this issue at the moment where they sort of have to almost make a choice. Do I go fast and actually get value out of the data, and typically not be actually legal with the data, not be GDPR compliant? Or do I go very slow and make sure that I am GDPR compliant? That's almost a catch-22. It's either one or the other. We think we have a pretty good solution for this. Our solution indicates that every event that Stream Machine receives, that the customer application creates, gets assigned consent levels, event level per event. So it can change for every event. Customers can change their mind continuously. And all the personally identifiable information inside an event is encrypted by Stream Machine. with a rotating key. We can go in details later, which means that after the encryption, the event is privacy safe. It no longer contains PII, personally identifiable information. So once Stream Machine has done the primary processing, the outgoing event stream is fully GDPR compliant. It can be used by anyone in the company with no hassles whatsoever. For more personalized activities, for instance, something like personalized marketing, you actually need consent levels from the client, from the customer, saying, I'm okay with personalized marketing. So this would, on event level, the PII data would still be encrypted, but those teams in a company that require those personalized marketing data, they would actually receive decrypted data where those fields are actually available for them. So a personalized marketing team would just subscribe to the event stream, which is okay for personalized marketing, and they would receive exactly what they have a right to. So problem solved there. The fact that we encrypt from start also means that if you decide that you want to store long-term data, you can just store the encrypted data, and if a right to be forgotten request comes along, you only have to throw away the encryption key, which might be a lot cheaper for if you have large amounts of storage, instead of actually changing the long-term storage data. So that's what Stream Machine offers as benefits. We take care of the technical part of streaming data. We are very experienced with the data engineering that is applicable, and privacy by design, not as an afterthought. And that's very important, we think. Okay, up to Robin.
All right, thank you, Bart. What Stream Machine offers is highly available event streams at any scale. This is done using the following architecture. This, of course, is a simplification of the architecture, but the ideas are still valid. So what we see here is several applications sending events to our gateway. That's our entry point. And what the gateway does at first is validating these events against the validation rules that apply to the schema that is linked to these events. For validation rules, you can think of, for example, regex rules. Certain fields should match a certain regex pattern, and if they don't match, the gateway will reject them. So when the validations have passed, the next step is to encrypt the personal identifiable information fields. For each personal identifiable information field, a different consent level can be linked to that. But all fields that are PII will be encrypted. These encrypted events eventually end up in the encrypted data stream, which is internally represented as a Kafka topic. What you also see in the middle are several decrypted data streams. And these decrypted data streams are optional. They are created upon request of a user of Stream Machine. And the large benefit here is that you can actually partially decrypt the events of the encrypted stream. So if you're interested in all events that have consent level 1, for example, you can request that these events, or actually the fields that match consent level 1, are decrypted. This decryption can either take place in the infrastructure of Stream Machine, or can be done at the user's infrastructure. What we also offer is an Egress Interface, and this Egress Interface is merely meant as a debugging interface, and is, it uses WebSockets and server-sent events to, proxy all messages from a certain stream to a developer to easily develop your your application that's using Stream Machine. Next up is the actual demo. So please hope that the demo gods are with us this time. We would like to show three things. The first thing is a sign up and a walkthrough of the schema that we will be using through this entire demo. The second one is a fictional web shop. So that more or less represents a real life use case which where you can use Stream Machine for. And the third part is the batch exports. So exporting large amounts of data from Stream Machine into, for example, S3 buckets or Google Cloud Storage buckets. So the first part that I like to show is our main website. You can read more on Stream Machine over here. What you can also do is sign up for our alpha. If you go to our sign-up flow, then everybody has seen such a sign-up flow. You can follow the instructions and create an account, verify your email address, and next you can start creating a stream and actually send and receive data using that stream. I already took the liberty of setting up an account, so let me log in over here. Whenever you created an account and verified your email address, you'll be presented with this. This is our portal. And the first thing you can do is create a stream. But before I dive into how to create a stream, let me quickly go to the schemas. So at the moment, there is only one schema available. As I said, we're in alpha, but more schemas will be added in the future. A schema consists out of two parts. The first part is actually shown here at the bottom, is the serialization schema, which can be of different types. Here we have Avro, but at the moment we also support JSON schema. We also have the ambition to support more types in the future. I won't dive into the details over here. This is an Avro representation of a schema. That's just how the payload is serialized, and that's how the gateway knows what kind of data is actually being sent. The top part that you see over here is the actual schema definition. This is what we call the schema definition, and it's a meta schema that describes certain things about the payload. The first thing is the schema reference, so the type of schema and the actual reference to the schema. The second thing are the validations. So the validations here are regex rules, and we see that the field customer ID, it basically says here it should not be empty. And for the URL, it should match the pattern here for a URL. The key field of the schema definition says which field in the serialization schema is responsible for tying events together. So which field links events in a sequence together. In this case, that's the producer session ID field. And the last part are the PII fields, and that says which field have which consent level. So here we say that customer ID has consent level 0, and producer session ID has consent level 1. The numbers over here are just a representation. You can tie any label to it, and in the demo we also have tied labels to them and do a translation there. So now that we know the schema, let's move along to our simple web shop. So this web shop, as you can see, it exists of 20 products. So you can't buy a lot over here, but it does the job. So there are enough products to actually scroll. You can click on a product, which will show a detail page for the product, and you can add them to your cart. So quite basic, but it does the job for this example. What we also have in the bottom left is a very simple cookie consent. And at the moment, I didn't select any cookie consent. And we also have this text box over here, which represents our customer ID. So we can fill out the customer ID here. That's because we don't have a login flow implemented here. But for the sake of the demo, I'll just fill out here OpenValue meetup. We implemented several events that are being sent to capture the behavior of the customer that is visiting this web shop. So whenever I click on a product, this will trigger an event. Whenever I add it to cart, that will trigger an event as well. Let me show you what happens when I actually when I listen to these events through the egress. So I have this function over here. Let me quickly show you what it does. So what it does, it consists out of two parts. So the first thing is we authenticate to our authentication endpoint, where we present our billing ID, our client ID, and our client secret. So these credentials, you receive them when you go to the portal and create a stream. Then you'll present it with these credentials. You have to store them. And I already did that for this demo, and I got them over here. For the ones that see these credentials, don't worry, we'll remove the stream after this meetup.
15 minutes.
So the next part is a Websocket command line interface. We'll pass along the ID token that we receive from our authentication endpoint, and we connect to our WebSocket, and we pass along a query parameter so that we actually get the data back as JSON, because then we can pass it to JQ. I want to reshape the events a little bit, because otherwise it's too much info to show on this screen. So let me actually run this. So it connected to WebSocket over here. So if I click on a model, then you see product 2, open model. Consent levels is empty over here, which is correct because I didn't fill out the cookie consent. The customer here, well, if you remember from the schema, it had PI consent level 0. So it means it's encrypted. Because actually what I'm doing now is reading the fully encrypted stream. That's why you also see that this data is encrypted. For the session, I abbreviated it here. This is the producer session ID. That's also encrypted, but that's of a different consent level. So of course I can close the model, and then it also shows. So let me also start the other stream. So we have two output streams that we also want to read: consent level 0 decrypted and consent level 0 and 1 decrypted, and they are increasing in my screen over here. So let me start them. And well, if I click the same product, I don't see anything happening over here. Well, why is that? That's because I didn't provide any consent over here. So let me switch to the analytical level. What I expect if events are being sent now, I expect events to appear over here. And as you can see, the event appeared over here. So it's the same event, but actually the customer here is decrypted. As you can read, it's broken up into a new line, but it says OpenValue meetup. It's the customer ID that I fill out in my browser over here. And as you can see here, the consent level also changed here. So the previous event had no consent levels, and now we have consent level 0 here. And I can repeat the same trick, of course, with marketing. There we go. So it was a startup hiccup. So that's why we say that this is a debugging interface. So it's only meant for testing purposes like these. So as you can see here, the consent level changed again. It changed from only 0 to 0 and 1. And if we look at the bottom stream, we see that the session ID is also decrypted, whereas the session ID was still encrypted in the second stream. So enough about that. Let me show you what happens when we go to the network tab. So if I actually click on a product, it calls an endpoint in our backend. Well, why is that? That's because of two reasons. The first thing is this way you can actually keep your secrets, your client secrets of your streams safe, because they are in your backend and not in your front end. The second thing is that we offer drivers for backend applications, and it's often easier to change backend applications than it is to change front-end applications. So let me also show that quickly in IntelliJ. Let me switch to presentation mode. So the endpoint that was just called was the model endpoint. Actually, what we do is we receive a model product event, which basically consists of two strings, the product ID and the action that was done on this product. Well, we want to send an event, and this is just a convenience method. But in the end, it creates a clickstream event with this data. So as you can see here, what you see over here is the Java class representation of this arrow schema. And we actually just build the events over here using these this Java class. Whenever we create an event, after that we send it with the Stream Machine client, which is our Java driver, and that's how it ends up at the gateway, and then it's validated. Let me quickly show you one more thing. You already briefly saw it, I think. So to show the power of Stream Machine, we implemented a simple JavaScript over here. Whenever you start scrolling, that you see that products enter and exit viewport, and this sends a lot of events. But this exactly is what Stream Machine is made for. These amounts of data at this granularity, and it's just up to your own imagination of what you want to do with this. All right, that's it for me. I'll give the word to Bart.
Okay. The last bit of the demo, it's a not yet released feature, but one of the things we will provide is that when you define a stream, you can just start a batch exporter, which will export all the events from your stream to a cloud bucket. Think AWS S3, or in this case, what I'll demo is a Google Cloud bucket. And what you will get in the bucket are batched groups of events per time slot, in this example per 2 minutes, of JSON lines, which is a very common format for data scientists, obviously. And the batch exporter is made in such a way that you will get exactly the events that came in that were accepted by the stream machine. No more, no less. You will get them all and you will get no duplicates. So it's idempotent writing with correct Kafka handling and such. And so this is a very small sample set. We actually built it, I think yesterday. Unfortunately, not from Robin's demo, but from a load generator test that we have. And let me see, where is it? Ah, there it is. Oh, let me just get a bit bigger. So one line of data will be something like what you see here. So it's a JSON representation of the arose schema. So this is what the bucket you saw consists of many lines, multiple files of many lines of these. And we actually, we just this morning created an interface to BigQuery, which is a Google SQL interface to buckets. Amazon has the same, I forgot the name. Athena. So Athena plus Amazon S3 is pretty much the same thing. And let me see. So here, it's extremely easy to hook up these two. So this is a data set. This is the one that I did this morning, but I'll show you how this works. You say, add a new table. The mouse is a bit shitty. Google Cloud Storage. Let me find first of all, it's not Avro, it's JSON line. Oh, I must have to look at my screen, that's easier. And I don't pick one file, I want them all. Star. Okay, let me see. Batch exporter, I'll give it a name. OpenValue. I say auto detect. I actually say that the table is the original data. Let me see, JSON, blah, okay. There we go. Go to table, query table. Now let's take all of them. And there we are. How do I get this bigger? Oh, there it is. So here's a SQL query for your event data. I have a few saved queries here. Project queries, for instance, this is a count for a group by the different A/B tests that we have in the events. And there it is. Well, I said it was from a load generator, so they're all pretty much identical. So I have a couple of events for A, for none, and for A and B. So it's very easy for your data scientists to work with these data at a batch level. This is on a closed roadmap. It will be done in a few weeks. That is live for customers. Just click and you have your bucket output. This is the end of our demo. So the demo time. Well, the demo gods were with us. Present. So that's not so bad. If you want to try more, Stream Machine IO shows you the steps. We have this, we have live, we have a blog post, we have documentation. It's still early, but it's not too early to use. Any questions?
Okay. Thank you very much, Bart and Robin. That was really an amazing talk, and you showed quite a lot last 30 minutes. A great working demo. And it's especially impressive if you know that you've been working on this basically with two developers together with both co-founders for just this year. Actually, I think you started somewhere around June or July, and that you already have come this far. Really, really amazing. So there is actually a question in the chat I would like to relay. Frank is asking, hi, if we were decrypting on our own hardware, why would we need partially decrypted topics? Can you maybe clarify that a bit, please? Bart or Robin, please.
why would you need it?
Yeah, so yeah, I think you
Pa-
maybe
partial,
touched on it.
partially decrypted, that's actually, that's an easy answer because GDPR says that you should collect data for a certain purpose. And if the data was collected for another purpose, in this case, another consent level, then you're not allowed to look at that. So we provide a mechanism that the people receiving the data, the teams that receive the data, will only get the data they have a right to. That was consented by the customer. So that's solved. And of course, you could, we pretty much explained how our system works. You could build it yourself, obviously. But we also solve the operational issues of working with this kind of stuff at scale. Yeah, we're already running it at 10,000 requests per second. So we handle both the privacy and we handle the privacy aspect, we handle the data quality aspect, is a very important one, which almost glossed over it, but we can apply complex rules to the content of your data. And we handle streaming data processing at scale with fault tolerance and such built in. So I think we'll eventually be cheaper than a do-it-yourself solution.
Well, I'm pretty much convinced that it will be cheaper. If I know the amount of research that went into this system
Yeah.
and the problems you solved, the technical challenges, and how you overcame them, for sure. Thanks very much also for the explanation. And GDPR is, of course, something that we're just realizing what the real impact is. And a lot of companies out there still need to do a lot of work before I think they're truly compliant. And I think Stream Machine can be potentially a really good fit for a lot of organizations.
I think this company was founded from a lot of real knowledge on what GDPR means for real stream processing. So the legal issues are sort of at the core of the design of this thing.
Yeah. Okay. Well, Frank says, okay, thanks for the question. And Robin wants to add something, please.
So, I think the question was more aimed at the topics. So why would you need the decrypted topics? If we run the decryption process in our infrastructure, then we need those decrypted topics. Because that's how we keep track of the decrypted streams. But if you would run it on your own hardware, well, then you're responsible of what you are going to do with that.
I see. Yeah, that's a really good addition. Thank you very much for that, Robin.